All right, so we do have them all back up here again. A few questions. Get us started. Anybody feel brave enough to come back up at the end of the day?
Well, thank you.
Yep.
Hello?
Yep.
Yeah, Patricia, thank you for that presentation. It's very good. I was just wondering if you could speak to the data sets that you didn't include in your analysis. Is there any question around the quality of that data set and maybe any improvements we might need to do to the water quality program, maybe to improve the quality? I'm just interested in your thoughts on that.
I presume you're referring to the fact that sort of we pared the parameter list down. A lot of the I guess selection of the parameters really came down to comparability of methods, and when we poured over the methods for the parameters, we felt that some of the methods weren't comparable, and I can specifically think of examples where different extraction methods were used for total metals. So we didn't feel that we could adequately put those data into our analysis because the extraction techniques were very different and would likely result in different concentrations, even if the sample was split and sent to the two labs. It was the same sample, but the numbers were going to be very different. So that was the one methodological was the issue related to different labs employing different methods. And then the other aspect came around to also methodological, but was detection limits. And some of the labs had detection limits for the same parameter that were very different. And I really think that if we're going to be sort of pooling data in the future, that's a key area that has to be considered, either comparable labs or assessment of the data as to its suitability for pooling.
Okay. Thank you. Another question at this one?
Yeah, a question for Kevin and Michael regarding air sheds. And we heard Dr. Taylor this morning talking about the importance of working with groups that are already established, have been doing monitoring, and as we heard in your presentations, you've been doing lots of monitoring for a long period of time. And I'd like to get your perspectives on how we make sure that we don't lose the capacity that we've built up with air sheds in the province as we transition to this new paradigm that we're in with Emera. And I know I'm putting you on the spot a little, but that's what we're here for.
Yeah, I don't know whether to thank you, David, or that's a good question. Certainly, Dr. Taylor mentioned this morning. He mentioned a number of organizations by name. I think the province needs to retain the capacity that has been built in these two air sheds and strengthen it. I don't think there's any way around that. I cannot see myself, a centrally based organization, say in Edmonton or wherever it happens to be, being physically on the ground and doing what a WABEA or a LICA does. I think there's every opportunity for, certainly speaking for WABEA, to work as a really effective working partner with Emera for the common good. But I think there's certain maybe attributes in the WABEA model that have served us well over the years. One of them being the technical committees, where we have this. Somebody was mentioning earlier about how do you get the science into policy and decisions and so on. I don't really think it's that difficult. I think you just have to enable the structure, and not that WABEA is perfect by any means, but I think we've gone a long way towards that by having the regulator, the government, industry folks, Pembina and all the others in the room discussing technical things and giving advice on giving advice on work that meets scientific needs and at the same time meets community needs. And so I think these community-based, or in our case, regional-based organizations have a really important role to play if Emera is to be successful. I don't know if that answers your question, but I think if anything, they need to be strengthened, and Emera should use I think as Dr. Taylor was saying this morning, should take advantage of the capacity and the successes that are there, and build upon those. I don't know, Mike.
Michael?
I think if the public, particularly the public land, in the Leica case anyhow, the public stakeholders, if they feel their influence into the design and implementation of monitoring programs is eroded, I think and we're already starting to see that or hear that sentiment with some of our stakeholders. I think it's going to be really hard to keep an organization like Leica together. There are a couple of projects in the air work plan, the air component advisory work plan this year that I think will kind of keep, that'll keep the glue holding all the pieces together. But I think there's some, a couple of stakeholders that aren't happy about decisions being made centrally rather than locally. And it's taken like a long time to repair our image coming out of a hearing a couple of years ago, and I think I would be disappointed if we lose all the ground we've made since 2008 or 9.
Yeah, I think, sorry, can I just add one more thing,
Sure.
Rob? And that is a couple things, actually. I think certainly from 98 right through till, WBA's kind of always planned from the ground up to meet community needs, science needs, address gaps. And I think that's really important. If you get that consensus at the local, regional level, then everybody's on board. An example of how that has really paid off, and I think making us smarter as a community, we're both sort of opposite ends of sort of our work. One is that amazing work that John Watson and Judy Chow and DRI got done doing real-world emissions characterization on stacks for 2 weeks, let alone getting the companies to dedicate a heavy hauler for weeks and allow them to drill a hole in the muffler and mount all these systems. That was built from a degree of trust, I think, within WBA. Members being comfortable with one another and seeing the common good. So when we went to get mine haul road samples or bitumen or whatever, we were able to do that because we built this trust at the local regional level amongst the members. Another example is the TEK project we've had going that I kind of just due to time unfortunately glossed over. It's one of our more important projects, but I think without the active cooperation of the Fort McKay Sustainability Department, that wouldn't have been as successful as it is. That enabling that you get from trust built up over the years from within these groups, I think is absolutely critical going forward, and I would hate to see that lost.
Thank you. Bill Shoddock, University of Alberta. So just for Patricia, some general remarks just about the quality of the analytical data from RAMP for the trace elements. So I have looked at that data, and it's quite well known that there were some analytical problems with the data before 2007, very specific problems. And Alberta Environment folks could tell you more about that. But the data since 2007, which was measured at AITF, it's internally consistent, much better quality data. So certainly that data is worth looking at. But if you look at the data that's available, for arsenic and selenium, the challenge is the levels in the river are so low relative to the limits of detection. So if you look at the data that you showed, those selenium values are close to the limit of detection. So ICP-MS is really not ideal for either of those two elements. So in future going forward, the arsenic selenium should probably be done using hydride generation, atomic fluorescence. It's much more sensitive for those elements. And that way the data being reported will be well above the limits of detection. Arsenic is not so bad, it's manageable, but selenium is really problematic because it's so low. But the other point I wanted to mention, if you look at that data set for the town of Athabasca, so upstream of Fort McMurray, if you look at the seasonal variation from 2007 to 2012, so the Athabasca Watershed Council has now released the State of the Watershed report. Okay, it was on ice for 2 years. They've now released that report, and there's a summary of the data in that report. So the town of Athabasca, upstream of Fort McMurray, there's a beautiful graph in there showing the variation, seasonal variation in vanadium, okay, which is huge, but it follows perfectly with the dissolved organic carbon. So if I had to guess on the Athabasca River, what's controlling the vanadium is actually the DOC coming in the surface water, which I guess is primarily the muskeg drainage water. If you look at the average DOC in the river, it's about 5 ppm, so it's quite rich in humic material. And I'm guessing that's the real explanation of the vanadium. So those are my comments on the trace metals data.
The data that I was showing were from the 7 tributaries, including the Christina. So the Muskeg was just one of them. Does that,
The DOC is high throughout the watershed. You have so many peatlands in that area, and they're draining into the Athabasca River. So I think for a lot of the trace elements, what we'll find once we begin to start the work on the physical and chemical speciation, that the trace metals are primarily associated with that DOC.
thank you.
All right, great. We had a question.
Hi, Lucy Sliwa with Worley Parsons. I'm an aquatic ecologist, and I was kind of hoping to hear more about the results from the work that Environment Canada was doing, addressing various issues identified with the historical benthic invertebrate collection, including the lack of main stem monitoring. Wondering if anybody's got comments on that. I know JOSM was developing some methods for the main stem using the cabin approach, and they were also sampling the tributaries. It was Nancy Glossier was working on that, I guess. Pat, I don't know if you would you'd be familiar with it.
Yeah. In a general sense,
Yeah.
there were on the many of the same, well, all of the tributaries that I described, there was fall sampling going on using the cabin methodology, as I understand it, on each of and I think somewhere in the neighborhood of 50, 60, maybe more sites were sampled over the course of those, at least of those 7 rivers. The sampling, there's now been, I think, 3 years of data collected, 2012, 13, and 14 in the fall, and they've sampled sites, as many as about 14 or 15 sites on some of the tributaries spanning along the whole length of the tributary. Those data, I know that many of the samples are still just with the taxonomists getting analyzed, and I haven't seen the data interpreted at this point. Now, that's the tributaries. At the same time, there was monitoring in the fall going on in the Athabasca main stem, and these sites spanned from upstream of Fort McMurray all the way downstream, almost to the delta. They were sampling both the soft sediments. Well, they were sampling both major substrates and trying to cover habitats on both sides of the river at each of those sites. And as is the case with the tributary samples, to the best of my knowledge, those samples are still out with the contractor for identification, and I haven't seen interpretation of the data yet.
Yeah, I don't think there's interpretation of the data yet at all. There was another little sidebar study where we did a comparative synoptic sampling of the ramp techniques, the Neil Hess cylinder with the cabin kick and sweep. So those data I think are also outstanding. I haven't seen anything.
So is the plan to go forward with both techniques? It just sounds like there's a lot of duplication of effort, and they're completely different approaches too. One's the reference condition approach, and the other one's more of a long-term monitoring effort. It's just wondering, going forward with the Emera monitoring, if the plan is to go forward with the original ramp methods, or if the cabin's going to replace that.
Yeah, I can speak to that a bit. So one of the challenges we have in designing a benthic monitoring program for the region is that the cabin approach doesn't work in all the locations where RAMP has been monitoring benthos because the river is simply too deep. You know, with cabin, you have to be able to wade out into the stream and to collect the sample. And in some of the locations where RAMP was sampling, the river can be over 1 meter, 2 meters deep, and it's very muddy bottom. And so what they were doing is they were taking what's called an Ekman dredge and compositing those samples. And so that's been one of the challenges is been trying to come up with a consistent sampling approach, but that will also build upon some of the long-term data that we have for the region from RAMP, and also be consistent nationally with other efforts that are going on using the cabin program. And so, you know, that's an ongoing discussion between Emera and Environment Canada, and you know, we're working together on that, and a lot of that is going to hinge on those side-by-sides that were done, so on the comparison between cabin and Hess at the same place, and looking at how comparable the data are directly.
Thanks.
Great. Okay, we'll go over to this one here.
Julius Pretorius from AITF. Patricia, a question or a few remarks to you about data quality. I find it a bit strange that you focused so heavily on method detection limits to decide on data quality. I think there are much better ways. You should perhaps consider probing labs to give you their full quality control suite for a specific analysis. Any lab worth its salt should also be able to give you the uncertainty estimate for any measurement that they do. Looking at different methods or the comparability of methods, I mean, if you look at, say, total metals, whether you do a microwave digestion or a block digestion, I think the EPA has done lots of work to show that those methods are comparable, so you have to be careful there to just force things into one direction. And then, of course, the big elephant in the room, labs can do their very best, but if sampling isn't done properly, then your data set would be meaningless. So that's the other big thing to look at. So, thank you.
And I could point out that a sort of a small sidebar during these last couple of years, we have done sampling comparisons, and we've had the Environment Canada samplers out at the same time as the consultants were sampling as part of the RAMP program. We collected split samples and we sent them to our various labs. And many of the parameters many of the samples that were collected in the last 2 years did indeed show comparable results. I can't tell you off the top of my head which parameters didn't, but we did undertake that split sampling in several times over the past couple of years.
Okay, thank you. Question on this side?
Thank you very much for all your presentations on the monitoring side. I just wanted to get your opinion or highlight on the technology challenges you guys face in terms of long-term, in terms of monitoring, and how does that, the technology challenges are addressed in your long-term water and air monitoring roadmap between Emera and Environment Canada?
So are you, let me just
In
make
terms
sure I have so the long-term technological challenges or differences in measuring water chemistry?
In terms of what are the technology challenges you guys face when you're doing the monitoring? I do see there's a lot of comparison between different results and all that, but a highlight on that will be great, because I do see that you guys have presented a lot of data on monitoring, but very less information was presented on how what kind of data, what kind of technology was used in that, and what are the challenges you face.
Well, perhaps I could summarize some of the data collection methods and the technologies we've been using for the past, well, let me just confine it to the past 3 years under JOSM. I guess I could summarize and say we basically had 3 different modes of collection of water chemistry data. One was the deployment of water chemistry sondes. So these were devices that can sit in the river permanently, and they sample, unfortunately, only a limited number of parameters, often more physical parameters like conductivity, pH, temperature, dissolved oxygen, although some are capable of also sampling some of the forms of nitrogen. And they can sit out there, well, often for months at a time, depending on battery life, and can either store the data within the probe itself, or in some cases can send the information by satellite to the receiver. So we had, in any given year, probably throughout the region, there could have been anywhere from 14 to 30 sondes operating at a particular number of sites. Then the next, that's the most independent, if you want to say it, way of collecting. We also had automated sampling systems, and basically these looked like drums that sat beside the river. They had a timer in them so that they sipped a sample from the river at either some time interval, or they had a trigger that was related to water level. So if the water level went up or down by a certain amount, the device was triggered and a water sample was sipped up tubing and stored in bottles in this drum-like device. And then whenever anybody went to the site, which was usually at a period of every few days to maybe a week or two, depending on the time of year, these samples would be collected and then could be sent to the lab to be analyzed. And then finally, I guess the other way is to do a grab sample. So somebody's there, they dip the bottle and they grab the sample. So the least technologically advanced, I guess you'd say. Does that answer the question?
Yeah, I'm more interested is like, yeah, when you guys are talking about long-term monitoring and all that, what is the automation systems which you guys are looking into? The Environment Canada, what are the technologies are you looking into some new, like how does it match to international standards? Like I'm sure in Germany they have more automated system of monitoring, more advanced level. How does the Canadian technologies in par with them?
Well, yeah, the monitoring, the technology used for monitoring is determined by both what is needed at that site and the frequency that you think you need to be there. Perhaps it's a remote site that is not a lot of activity in the watershed, so you don't think you need to have a lot of samples. You maybe just because there's not a lot of human influence. Other sites where you think there's a lot of human influence and that could be highly variable, you want to be there much more frequently getting data. The problem is that a lot of remote sensors, ones that are battery operated, collect only a limited number of parameters, and you refer to places like Germany or even places that are well urbanized in the United States. They may have automated samplers that run off of the mains, the power, and so they can sit there and sample very frequently because they have access to they have access to the main power as opposed to a battery. And that's really a restriction on some of the types of technologies that we can use. If we put out a sampler that we only have battery access, we can't sample as frequently. The other aspect that comes into play too is that a lot of the samplers that do the more sophisticated chemicals on site have to be up on shore, and they have to, so you can only really put them there when you're certain they're not going to be washed away in snow melt or high flood conditions. So that limits our time period that we can deploy them. Say, compared to, you raised the example of Germany, where the rivers are much more regulated and the weather conditions aren't as variable. The other aspect comes into play is, of course, we've got severe winters, and some of the equipment that's placed on shore just won't operate. It freezes up during the winter. So to take technologies from other countries, we really have to be certain that those technologies are addressing the questions that we want them to answer, and they're suitable for our weather conditions.
Okay, did you have a comment?
Yeah, you've raised a good question. I'd like to, if I may, try to answer it a different way, and that is most airsheds tend to use US EPA federal reference methods, sort of the gold standard, if you like. In air, it's clear that the US EPA or CARB, the California Air Resources Board, they really do set the international standard. So for the routine monitoring, not the research monitoring, but the routine stuff, and so I think it's really important that as we go forward, or as Emera goes forward, that we don't get complacent, and that we just assume because our data is complete and we think we're doing a good job, that we are. We want to be continually challenging ourselves, and I know in WBA for years now we've been sending some key people to, for instance, a big EPA-led conference on current future status of monitoring particulates. This enables folks to actually get a jump on the new regulation or the new methods that may be, say, in 2017 coming down the road for the states on how to sample VOCs. It may change quite considerably from what everyone's doing now, but one ways to do that is that I think when Emera considers funding proposals, they have to ensure that there is a certain proportion of funds that are always available so that we can stay smart, and we can do technical projects. We can sort of keep trying to push the envelope to get better. Otherwise, monitoring can just become a routine data collection exercise. It becomes a business rather than something that's driven by trying to be our best. So.
Okay, good.
Thank you.
Thank you. All right. I thought one of the more interesting monitoring one was the ones where you get to sniff the bottles. I was wondering next year of the symposium you could bring the odor bottles and we could all have a smell, and with scotch in the bottles perhaps, or.
There has been discussion technically in the field whether N-butanol should be the only standard odorant, but scotch could be a concept that we could do at different levels.
So that which is kind of one of the. Oh, sorry, we had Prasad.
Yeah, sorry, Rob. Just I had one more question, and maybe I'll put Heather on the spot here. And Heather, I really appreciated your presentation because I think that analysis of fish with water quality, water quantity, trying to integrate information, I think that's where Emera wants to go in the future in terms of more integrated reporting. So it sort of tells more of a story as far as what's happening in the environment rather than just having a fish report and a benthic report and others. So I really appreciate your presentation from that perspective. But I wanted to ask you, how did you find that sort of analysis? Did you find challenges with that? And what sort of recommendations do you have for more sort of integrated reporting?
Is this on?
Yeah.
Challenging, I mean, the RAMP program developed over time by continuously adding stations. I think, the benthos in the water and the sediment have always been co-located to provide supporting data from the chemical side to the benthos as being analyzed. So that's always been pretty strong. Adding the fish community work, in 2009, the RAMP fish program was reviewed by some people from US EPA down in the States who does a lot of fish community monitoring in the States, and they recommended this approach and tying it into the other components. It's taken, we rolled it out in 2009 as a pilot study. The challenge was figuring out the methodology and how to effectively sample and coming up with the endpoints that would potentially assess any change. There's a lot of challenges with fish work in that region. it's fairly low abundance, low species richness of fish in those tributaries. So that, and compared to the US EPA kind of work where they're going into rivers that have over 100 fish species, we get on any given day at the most 20 species in the main stem, but you're looking at 9 or 10 fish species in some of these smaller tribs. So there's definitely was challenges to come up with some performance indicators or endpoints to look at over time. But a lot of the work that Bruce has done with the benthic data set certainly helped to pave the way in terms of how we analyze the fish community data. We're kind of adopting the same methods. Bruce and I have been doing a lot of data analyses over the past couple of years to really work out how we can reduce noise in the data set, how we can use the fish habitat data to try to develop a method forward. But I think, there are some caveats to looking at the fish community and whether that can detect a change given how much variability there is over time and between years, as well as the abundance and the richness in the rivers. So I feel it's an ongoing process. We only have 6 years of data at the most for some of our tribs. Some of our tribs that have just stations that have come online in the past couple of years, we only have a couple of years of fish data. We've tried to use as much of the AOCERP fish data from back in the 70s or 80s to try to tie in. The problem is it's very difficult to compare fish data over time if you're not using the same sampling methodologies. So we've more looked at like species presence and what's there to try to compare back in time. But definitely it's an ongoing evaluation. But I think being able to, when we review the RAMP report and we review all the data together, you get a much better understanding of what's happening in a river by looking at everything together.
Thanks, Heather.
Maybe I'll just add one thing to that, Prasad. I would just add that there's really, the water program is fairly well integrated at this point, and there's really no intention to unintegrate, is that a word? To unintegrate it at all. I think one of the challenges we're going to have, though, going forward is integrating the fish, the benthos, the water, the sediment with the air program, and really trying to merge the work that WBIA has done with the work that EC's done, with the work that Emera is doing, with the work that RAMP is doing, right? And to really try and merge those and to sort of get at a mass balance kind of perspective. And so I think that's really going to be the challenge going forward.
Okay. We have one more comment over here, I believe.
My comment too was related to the fish program. I know we talked for a long time about relating, effects to cause and how you pulled in the flows and the hydrology in the wet years, dry years, and related that to, say, catch per unit effort. I thought that was just completely going in the right direction of integration. I know we also talked about comparing young of the year abundance to temperature dynamics and flow dynamics, and I know that's Mark McMaster's work, but can you comment on where that's been and how successful that has been to that to the integration of the results and I guess some of the causal interpretations of them?
Unfortunately, I can't talk to that. I haven't really caught up with Mark on what he's doing. I do know, so I think they started putting data loggers at all the tributary sites. I think it was actually 2012, unfortunately, which was the really high flow year, and things didn't go very well for us. But I know, so we probably have about 3 years of data, but I'm not sure what the outcome is. Sorry.
That's okay. Great. Thanks.
Okay, great. All right, a round of applause for the panel, please. Well done. So at a few of the presentations, you've heard people refer to the post.